How do PDB files help debuggers map machine code? Imagine trying to read a foreign language without a dictionary. That's what debugging raw machine code feels like. PDB files act like a translator, making sense of complex code. When you compile a C++ program, the compiler creates machine code that your computer can run. But this machine code is hard for humans to understand. That's where PDB files come in. They store detailed information about your source code, like function names, variable names, and line numbers. This data is kept separate from the executable to keep it small and fast. When you start debugging, your debugger loads the PDB file linked to your program. The program itself contains pointers to where the PDB file is stored. The debugger uses this information to connect the current machine code address to the exact spot in your source code. So, when your program hits a breakpoint or crashes, the debugger can tell you exactly which function and line caused the issue. This makes fixing bugs much easier. PDB files also hold data about data types, symbols, and call stacks. This helps the debugger interpret the program's state during runtime. For example, if your program crashes, the debugger can use the PDB to show you the function and line where it happened. This speeds up finding and fixing bugs. In C++ debugging with tools like GDB or LLDB, which usually use dwarf format, PDB files are a Microsoft-specific format mainly used with Visual Studio on Windows. Still, understanding PDB files helps when working across different platforms or using cross-platform tools. To get the most out of debugging, it's important that the PDB file matches your exact build of the program. If it doesn't, the debugger might not be able to map the machine code back to the source code properly. Debuggers look for PDB files in the same folder as the executable first, then in build directories or symbol servers if configured. When you use the debug option in Visual Studio's linker, it creates and links the PDB file automatically. Sometimes, developers generate partial PDBs to speed up builds, but that can limit debugging capabilities. Overall, PDB files act as a bridge connecting raw machine instructions to the original source code. They help debuggers show meaningful information, making it easier for developers to understand what their program is doing and where bugs hide. Knowing how PDB files work and how debuggers use them is a key step in mastering software debugging and fixing issues efficiently.